All right, in this video, we are going to configure inter-VLAN routing with switch virtual interfaces. Last time we worked on configuring router on a stick, and just as a little review, router on a stick allows for us to use virtual interfaces on a router or a firewall to form multiple virtual, essentially, trunk links between the router or firewall, let's call it a gateway, and the switch, a layer 2 switch. And it's not as scalable as the inter-VLAN routing with switch virtual interfaces because we run the risk of creating bottlenecks at this link right here, right? And so we might want to deploy a multi-layer switch in order for us to have a more scalable solution utilizing switch virtual interfaces. So switch virtual interfaces are simply virtual interfaces that are created per VLAN to serve the end host in each of our configured VLANs, right? So I have a few notes here, and I hope you all can see it. I tried to make it as readable as possible, but I put some notes here on the screen. I put the interface, the CLI commands for the router on the stick configuration, and you can walk through that and play around with those commands as you see fit. I'm also going to be including chapters for each step here, so you can skip through my rambling and go to whichever particular part of the video that you want to go to if you want to brush up on something. And I would also urge you to follow along on Packet Tracer and CML if you have it. Remember, CML 2.8 now has a free tier that you can use to configure these devices. And the difference between CML and Packet Tracer is simply that Packet Tracer is a simulation, CML is an emulation, and you can do more with CML versus Packet Tracer. So let's get down to it. The first step we're going to do is we are going to log into the multi-layer switch, enable conf t, and we're going to give it a host name. Host name, let's call it a multi-layer switch. Multi-layer switch 1. Right now, if you are following along on a physical lab and you got this physical lab equipment from eBay or whatever website, you may or may not have to enable routing manually by issuing the IP routing command. Now, I'm not going to do that here because routing is already enabled on this switch, or so I believe, but I believe this is how you would do it, right? You go into config mode and you issue the IP routing command. Now, I believe I have a layer 3 switch behind me, and it's a I think it's a 3750. I can't really remember, but I know that I have to issue SDM prefer LAN-based routing. That's a command in the enable mode to, I guess, activate routing or something like that. Didn't really to read up on that, but I do remember that's something that I had to do when I was working with physical equipment when I was studying for the CCNA. But anyway, the first step you want is to configure or activate IP routing. Next step is we are going to configure and verify VLANs for endpoints on the switch. Simple enough. So we're going to have VLAN 10, 20, and 30. So we got VLAN 10, VLAN 20, and then we have VLAN 30. Now I want to show you something real quick. For some reason, when you verify before, when you attempt to verify before getting out of the VLAN configuration mode, it doesn't show that the VLAN was configured, right? So what I like to do, exit out, it's obviously doing something, and then I do show VLAN, and it's gonna show up, right? That last VLAN that I configured is gonna show up. Now, just to get a little bit, granular with it, let's go into VLAN 10, and we can configure a name, research, and then we're gonna go into VLAN 20. I'm gonna configure a name, engineering, and then we're gonna go into VLAN 30. Going to configure a name, and that is going to be sales, right? This adds a little bit more of a real world element, because that's what I do when I'm configuring VLANs. I like to leave naming convention so that people know which VLAN is which, right? It's a good best practice, right? So now do show VLAN. We configure and verify. Research, engineering, sales. Cool. We're gonna press Q, and we're gonna get out of there. So the next step is to configure and verify SVIs per VLAN, right? And so what we're gonna do is interface VLAN 10, and I'm gonna issue no shut preemptively, right? So we're seeing that interface VLAN 10 is in a down state, and in order for it to get to an up state, we have to make sure that that VLAN is active. And how we get that VLAN to be active is we assign ports to that VLAN and connect devices to that VLAN, right? I'm gonna show you in a second. All right, so now where are we? We're gonna do set some IP addresses. IP address, and I'm kind of like skipping ahead. Not really. So IP address 10.1.10.1 and a net mask of /24, right? We already hit no shut, and now we're gonna move on to VLAN 20, interface VLAN 20. I like to exit out so that I can keep track of where I'm at in the CLI. That's just a preference. You can very well jump straight to the next interface while you're still in the interface configuration mode of the previous interface VLAN configuration mode, right? So now we're in interface VLAN 10, no shut. IP address 10.1.20.0 255.255.255.0. Bad mask, yeah, because I'm out of, I have to actually configure an IP address, not a network, right? So we have that IP address. I like to exit out. Interface VLAN 30 IP add, and it's doing that because I should have configured logging synchronous to stop that from happening, but I'm being lazy right now. IP add 10.1.30.1 255.255.255.0. We already no shut it, right? I think so. I'm not sure. So we're gonna exit out, and then we're gonna verify. Do show IP in brief, right? So we have these VLANs now that have interfaces on them, and these are the IP addresses. So now we're somewhat ready for routing. These IP addresses are going to be configured as default gateways, so that when an end host wants to communicate with end hosts in other VLANs, it can very well do so through their respective default gateways configured on the interface VLANs, right? So, or VLAN interfaces. I'm going to exit out. I like to come back and then gather myself and see where I'm at. So the next step is we've configured the VLANs, right? Show VLAN. We got the VLAN set up. Cool. Now we are going to check on the show IP int brief. We see all of our interfaces here. Cool. Right? And now the next step is we're going to configure and verify DHCP pools. Now, you don't have to do this when you're in the real world and you're doing this real world configuration. You can have servers where you statically configure IP addresses, and therefore you don't necessarily need to configure DHCP, whether it's on your gateway or your router, but you might have DHCP sitting somewhere else on your network. Right. Again, in this example, in this demonstration, we're going to configure DHCP, but we're going to do it on the switch. On the last demonstration, we configured it on the router, right? So let's get started. Conf T, going back into configuration, global configuration mode, and then we are going to start deploying some DHCP services for each VLAN respectively, right? So it's IP DHCP pool VLAN 10. Matter of fact, let me make that capital. So this is the pool name, right? It has no technical significance beyond a naming convention. So we're going to specify the network. I don't like all caps, but we're going to roll with it. Right? That's the network. The default router, which is the default gateway, is going to be the SVI interface IP address here, right? 10.1.10.1. DNS server quad 9, right? And then I like to come out just to keep track of where I'm at in the CLI. IP DHCP pool VLAN 20 network. Caps got me again, huh? 20.0 255.255.255.0, and then we're gonna do DNS server default gateway, which is specified as default router here. 10.1.20.1. Let's exit right back out, and let's hit the up arrow to kind of save time, right? This is where you can make mistakes though. You're liable to make mistakes when you try to take shortcuts like I'm doing, and it's probably not the most ideal thing. Let's hope I don't make any mistakes, because we don't want that. This is for VLAN 30. Boom. We're done with that, right? So we have our DHCP pool configured. Now let's verify. So all of this looks good, right? Right, all of that looks good. Let's press Q to quit, and let's get out. And what's the next step? So we're going to connect our endpoints. The endpoints are already connected. Oh, I did skip. Configure and verify access ports to VLANs, right? So that's an essential part. These configurations are not necessarily in any specific technical order, if you will. So you see that I skipped step 3 by mistake. And now we are going to configure, make sure that this is in the center so that everybody can see it properly. Hopefully. We're going to configure and verify access ports to each VLAN. And that's essential because that's what's going to bring up our SVIs. So we are going to do interface G. I got to check which one this is connected to. Connectivity. So for research is 1 0. All right, so 1 0 switch port access VLAN 10. All right, let's get out of here. And we're gonna do, the next one is 2, which is for engineering. So we're gonna do using that up arrow. So this is 3. VLAN 30. Right? Now you see the interfaces coming up, right? Should see them coming up one by one. Because the devices are sending traffic. It's active. Switch is active. The VLAN is active. Let's see if the other ones came up. Yep, the other ones are coming up now. They're taking their time to come up. Let's see. 30 should come up soon. Yep, 30's up now, right? So now we have traffic moving throughout the VLAN. And let's double check to make sure that our end devices got the proper configurations here. All right, so if config, and it did, right? This one is in VLAN 10, research VLAN 10, right? VLAN 20, engineering. Let's check sales now. IF config. There you go. Also, if you are using CML, this is how you start the DHCP process. I like to do it because, I don't know, it feels like it's easier for me. And also I like to get some traffic flow going. It's a great way to get some traffic flow going, to test things and stuff, at least in my mind. So this is a server node that I'm using. I'm using a server node, right? So out of these many nodes that we have that we can use, and that's what this is one of the benefits of using CML. You have different things that you can deploy here, right? I'm using the Tiny Core Linux server, right? And it shows you the commands down under the example, but I like to just do my own thing and utilize this. It makes it so much easier for me. So now what's the next step? So we know that the SVIs are up. Let's go back to our switch and we connected endpoints. Now we can test connectivity between VLANs and respective default gateways. But before we even do that, we need to check the routing table to make sure that routing is working, right? Or make sure that we're in a good position for routing, right? Show IP route. And so we have all of the networks in the table now, right? We know how to reach each network. The switch knows how to reach each network. That's a good sign. And let me just rewind. How do we know that the switch knows how to reach each network? Well, the routing table says it, right? It says this network here is directly connected to VLAN 20, which means that if you want to reach hosts that are within this subnet scope, go ahead and send it to interface VLAN 20, right? So let's take a look. Let's ping the default gateway. It's reachable, right? And this thing will ping forever if I don't stop it. So Control Z to stop it. Now let's ping. Oops. We're gonna ping from research to engineering, right? Okay. It works, right? So the traffic is flowing like so. It's going from research to the switch, and all of the routing is taking place right here. Then, boom, hits engineering, and then engineering sends a pong back, right? Ping, pong. That's how I like to think of pings, right? I mean, isn't that how the naming convention came along? Anyway, so we know that research can ping engineering. Research can also ping sales. So I have faith that everything else pings, right? It pings, right? Boom. That works. So it's able to ping, pong, back, right? Because the switch has all of the necessary routing in this table, and we're able to ping. Now that that's taken care of, if we wanted to, we can add another VLAN, right? Like development or product or whatever, right? And we don't really have to worry about performance issues because I assume that we're gonna spec out what needs we have for traffic flow and all that stuff, and we're gonna pick a good, solid, robust switch that'll handle as many VLANs as we want to configure, reasonably, of course. Now, there are two, so we have routing between VLANs, but we don't have routing out to the internet. And how are we going to do that? How are we going to get out to the internet? So what we want to do is build out a transit VLAN to the router, right? It's not my favorite way to get a link to the router because sometimes I fumble it, you know, because it's very odd. You're gonna see in a second, but that's one way to do it. I've done it before in the real world, and it's depending on the equipment that you have available, it can be kind of weird to configure. I'm also going to show you how to do it via the routed port method, where you're simply making this port right here a routed port, such as a port that you would find on a router, and linking it to this port right here on the router, which is a routed port, and it's just a point-to-point link. Simple, straightforward, right? But we're gonna do things the hard way, because I think that when you have more tools in your arsenal, you can get creative with the resources that you have. And I know that firsthand, right? I work with a bunch of different types of equipment, but as long as I understand the networking concepts, I can design and configure what I need to design and configure within reason, though. All right, so let's go. We're gonna configure this transit VLAN. First thing we're gonna do is build out the transit VLAN. Let's do VLAN 99. Oops, we gotta go into global configuration mode first, right? VLAN 99. Name transit VLAN. Nice. Let's come out. It does its thing. Do show VLAN. Configure and verify. Always configure and verify. Transit VLAN, right? It says it's active. So it says. And the next thing we're going to do is configure the interface interface VLAN 99. It's going to show that it's down. Shows that it's down. We're going to configure the IP address. Oops. 10.1.99.1. And we're going to use a /30. Boom. No shut. Great. So the reason why we configured this interface VLAN is to connect to the routed port on the router, right? It's a very weird, to me, it's a very weird concept because this is an access port and it's a very weird concept. Anyway, now we need a port to be associated with that VLAN, right? Excuse me. Get some water real quick. All right. So, what's the next thing we need to do? We need to associate a port with the VLAN in order for that VLAN, the transit VLAN, to bring up the VLAN interface, right, for the transit VLAN. So, interface G00 switch port access VLAN 99. Right? Cool. Great. It may or may not come up. But now we're done. We're essentially done here, I believe. Right? Essentially done here. So now what we're going to do is we are going to come over to the router. We haven't touched this the whole time. Conf T, hostname, router. Let's call it router. Fine. And so now we got interface G00, IP address 10.1.99.2, point to point, right? So we are going to do a /32. No shut. And let's see if it came up on the switch. Change state to up. So it's up. Now, theoretically, we should be able to ping that IP address that we just configured on the router, right? And so that's what we will do. We will do ping. And it works. Great. But I know this is a lab, but we need to also think about, again, the real world application. If you try to access the internet from one of these nodes, you won't be able to do that, right? Because this switch here doesn't have a default route to router 1. A default route essentially says, hey, any packet we don't have a network 2 or a network 4 in our routing table, a routing match to, send it to this default gateway, right? Or send it to this device. So let's take a look at the routing table. Gateway of last resort not set. I like the vernacular here. Gateway of last resort. It's essentially what I just described. If a router does not have a match for a packet to a specific network, it first attempts to, when it gets the packet, it attempts to find a network. The last resort checks its routing table, and if it's set, boom, it sends it to that that default gateway, and the ISPs and the internet, that'll sort it out, right? And speaking of the internet, I'm learning BGP now because I have a situation at work where I have to configure BGP. So I might do a live stream on us just trying to figure out how to configure BGP in CML. So We can figure this out together. It's going to be like a little study session. So be on the lookout for that if you want to learn BGP with me, right? Okay. And also, if you have expertise on BGP and you watch my channel, feel free to pop in, right? Because I know there's a lot of people out there that are willing to help me learn, help me grow and get better. And yeah, so stop by. All right, so let's continue. We're going to configure the default route, right? So we're going to do that by doing IP route 0.0.0.0 255.255. Ooh, not 355, 255.255. And so we all know what this means. All of this is just saying any network, any subnet mask, send it here. 10.1.99.2, right? We're going to send it to this router right here, right? Boom. Do show IP route. Now we have a gateway of, oh, wait. It says gateway of last resort not set. Hey, look, I don't know. I guess I don't know what that means. But we have this set. I mean, I thought gateway of last resort was this. But hey, maybe it is, maybe it isn't. Let's see. Let me Google gateway of last resort because I thought that's what that was. Let's see here. Google. Oh, okay. All right, let's see here. I'm on. Okay, well, that wasn't the site, right? Gateway of last resort is a bit easier. This term is associated with layer 3 routing tables. It is essentially the same as default route and describes the next hop to which you would forward IP packets whose destination address did not have a match in the layer 3 routing table. So I guess I was right. Default gateway is more difficult because it is used both in context of layer 2 and layer 3. So let us start by considering the IP. Okay, so I'm not going to get into all of that. Shout out to the Cisco forum right here, Richard Burtz. Shout out to him. So yeah, I was right. So gateway of last resort, if you have no other place to send it to the gateway of last resort. That's set. It's great. So let's move on here, right? So all right, so we have that static route set. We just did a quick Google. Now, we have configured the transit VLAN between the multi-layer switch and the router. So any device that needs to access Google, for instance, like we just did, it's going to be, the packets are going to be sent up through the switch, up to the router, and out to the internet. This is the internet over here. This dark, murky abyss of routers and service provider equipment and all that stuff, right? So the next part that we're going to get into, or the next thing that we're going to configure, is just a simple link between the layer 3 switch and the router, right? And so how do we do that? So let's go back to the router. Let's make our lives difficult real quick. And let's do make sure I'm in the right interface. Always make sure you're in the right interfaces before you configure anything. You just never know. Interface G00. No. Matter of fact, no. We can keep that IP address there. Keep that IP address there. Also, I'm sorry. Let's do a rewind real quick. So the reason why the SVI stuff works is because they allow for routing, right? So when you have VLAN 99, right, as our transit VLAN, and you've configured this VLAN interface within the same subnet as this interface here, while connecting this port to that port, and this port being in VLAN 99, I'm guessing it creates some sort of weird scenario where that port right here is like technically no longer an access port. It's more like a routed port, but not really, because the routing is not taking place from that port, but virtually with that VLAN 99 interface, that transit VLAN interface. That's how I look at it. I try not to think too hard about it because it's not something that I typically configure. When I want to do some sort of routing between devices, I typically just set up a routed port, or these devices both have routed ports, and then I'm able to route between them or whatever. But this is very interesting to me. It's always been an interesting topic for me, right? Because I always think of switches as layer 2, and obviously we have multi-layer switches that can do layer 2 and layer 3, but it's just this weird situation where this is an access port and whatever, right? So let's keep it moving. The next thing we're going to configure is routed ports, or a routed port on the layer 3 switch, so that we can create that same scenario, but just via a different method, the routed port, right? So let's go back here. Interface G00. First of all, let's do this. Let's get rid of this. Interface VLAN 99. No IP address, right? So we got rid of the IP address. Let's verify. Do show IP in brief. I'm sure there's a better command to parse out all of this, but come on. All right, so we got rid of that IP address. Now, what we're gonna do is go into interface G00, which is the interface connecting to the router, and we will say no switch port. Now this port has become a routed port, right? Up interface, it's up for some reason. I guess it automatically goes up on layer 3 switches or multi-layer switches. Either way, all good. And then now we're going to take that IP address that we had on the VLAN 99 interface, and we're going to put it on the routed port interface within the same subnet as the G00 port that's on the router, right? Boom. So do show IP in brief. There you go. Also, another command that I like to use every now and again, do show interface status. I like using this, right? It shows you which VLAN each port is associated to, and we can see here that this port is a routed port, right? And it is set to auto, full speed, auto, whatever, right? Every other port we see here is in VLAN 1, but again, best practices when you're configuring networks, you shouldn't leave these ports in VLAN 1. Configure them to be in a VLAN that is not being utilized, right? So take a random VLAN, put it in that port, shut the port, take a random VLAN that you're not using, associate those unused ports to it, and then shut those ports down, right? So then see here, G10 associated with VLAN 10. This port is associated with 20. This port associated with 30. It's a cool little command that I like to use to keep track of everything. All right, so now we set the routed port up. We verified everything. Do show IP route. Now we see something a bit different here on the routing table. Now we see that this network is directly connected to this port right here, right? All good. So let's ping that router. Ping 10.1.99.2. Oops, we got to do ping because we're in global configuration mode. Success, right? So we got rid of the transit VLAN, which was VLAN 99, right? Oops, do show VLAN. Do show VLAN brief. Right? We got rid of the transit VLAN. There's no interface or any of that stuff in that VLAN. And we instead use the routed port to connect to this router so that our end devices have a way of reaching the internet or networks outside of this device right here, right? So that's essentially what I wanted to show you. I showed you in the last video inter-VLAN routing with router on a stick, used mostly for small to medium size organizations. And I also showed you, exposed you to some of these commands that you could play around with on your own. And then I also showed you just now inter-VLAN routing with SVIs, where we configured some SVIs, some interface VLANs, right? And we know that with these interface VLANs or the VLAN interfaces, we're able to communicate locally on this one hardware between these VLANs, right? Which I would assume is typically faster because everything is done on the device, doesn't have to traverse any links. There's no risk of saturation of that link, etc., etc. And this is more scalable, right? You can go from large medium to large network infrastructures. And I think that is ideal for, again, when you have the resources necessary and you have the spending power to have these switches that can do all of that on one switch, right? So yeah, that's pretty much it. I'm trying to think of anything else that I want to show you. I would also recommend that you get some sort of textbooks, some sort of subscriptions, so that you can dive deeper into all of this stuff, because I just show you the basics, and this video has been going for almost 45 minutes now. So if I were to dive deeper into a lot of the other aspects, which I try to stray away from because we can go down into a rabbit hole of technical stuff, but I think one of the most important things is to actually know how to do this. If you know how to do this, then you can build networks, right? Or at least you're at a starting point to where you can build networks. And I always recommend that people do what I'm doing with regard to creating a video or creating videos to build sort of like a quasi portfolio or something, to where you never know if you are, I don't know, sitting at some sort of convention somewhere and you meet somebody that is in charge of hiring at a company that you want to work for, or maybe you know somebody that knows somebody. They can just pull up your video and see where you are with your knowledge, right? And this goes for everything else. It goes for programming. It goes for systems administration, obviously networking. It goes for many different aspects of IT. this is how I got into the IT field, by demonstrating that I know what I'm doing. And I think I was lucky to get the opportunities that I got, but it also took a lot of hard work and tenacity through all of the sometimes throughout some of the journey. You know, some people tried to discourage me and all that stuff, but I just kept going. And the idea is just to keep going. Just get down and dirty and get the work done. You're not gonna be perfect. Nobody's perfect. You're not gonna be an expert on everything. You might not be an expert on anything, but if you're really good at something, build on top of it and keep the main thing, and keep an open mind, right? So that's pretty much it. If you guys are using CML, I'm gonna start downloading these labs, and if you're using CML, then I could just zip them up and then send them to you through my Discord server. If you want to join the Discord server, ask. So that's pretty much it. I'll talk to you guys next time. Peace.